Hello everyone, I'm Abhinay Peeta and I'm here to present my project detecting drug consumption patterns using machine learning. Our objective is to build a predictive model that classifies individuals as cocaine users or non-users using psychological and demographic features. Substance abuse remains a serious public health issue with physical, mental, and social consequences. This project explores whether machine learning models can forecast drug use, specifically cocaine, based on personality and background traits. The idea is to aid public health agencies and researchers with early warning indicators. And here we can see that a public health impact, usually substance users pose significant challenges. Potentially predictive models provide suggestions for public health planning, early intervention, and behavioral analysis. Coming to the dataset overview, using UCI drug consumption, like which contains around 1885 self-described profiles and 32 attributes, including demographical and personality trials, along with the history of drug consumptions. And all binary drug use outcomes were derived from ordinal drug users labels, and for cocaine the outcome included recent use CL3 plus irrespective of users lifetime. I used the UCI drug consumption quantified dataset because like it is including with the demographics, because it includes majorly the demographics, which is of age, gender, education, country, ethnicity, and psychological traits, big five: impulsiveness, sensation seeking. Coming to the drug use, self-reported use of 18 substances with usage level CL0 to CL6. Affirmed cocaine prediction as a binary classification where user equal to CL3 plus used in the last year or more recently. Non-user, which means CL0 to CL2. Coming to the ethical framework, uh, based on the sensitive nature of this work, I built it around four ethical pillars. First one is like privacy, anonymity, where data is anonymous and predictions must never lead the surveillance or labeling. Bias and fairness. Gender and ethnicity can introduce bias, so I used class balanced models. Coming to the use of predictions, these models should inform health outreach, not punish or profile. Explainability. We used SHAP values and feature importance to keep the model transparent. My personal stance is that ML should support, not replace human decision making, especially in the complex behavioral topics. Coming to the methodology overview, usually data pre-processing, renamed and cleaned 31 columns, encoded drug usage into binary values. Yeah, encoded drug usage into the binary values, handled class imbalance using class weight, which is equal to balanced standardized features. Feature selection, I selected 12 key input features, including age, gender, and all psychological traits. Modeling techniques, logistic regression, interpretable baseline, and the random forest method, which is used for nonlinear with better handling of interactions. And coming to the key data visualizations, which were made out of this. So figure one, stacked bar chart, showed most users uh, cluster around CL0 to CL2. In the figure two, coming to the heat map, it showed impulsiveness and conscientiousness as the key differentiators. In the figure three, pair plot revealed that high sensation seekers often had a high probability of cocaine use. The figure 4 and 5, box and violin plots confirmed behavioral traits like impulsiveness and SS are significantly different for users and non-users. Coming to the figure 6, so cocaine usage is clearly imbalanced. Only 417 of 1884 were users. In the figure 7, random forest showed impulsiveness. C and age are top predictors. And coming to the model evaluation, let's compare both the models on the test 20% hold outset. I mean, logistic regression, the accuracy is 71%, F1 score 0.50, ROC AUC 0.67, random forest accuracy 78.5%, F1 score user class is 0.24. So it had a better overall accuracy, but slightly poorer F1 on the minority class. Feature importance from RF confirmed that impulsiveness, age, and conscientiousness are consistently the strong signals. Coming to the final model, random forest, due to its better generalization of unseen data. So a common critic is that behavioral prediction oversimplifies human complexity. Transparency, we use explainable models. Educational use only. This is not for real world diagnosis. Aggregate level learning, we target trends, not individuals. Supplement, it's not a substitute. The model arguments public health insight. All the models were based on predicting behavior severe to simplify human acts. Their duties as academic object should be upheld by their didactic application. Their transparency, it emphasizes on aggregation and the possibility to orient the interventions. So mostly in the educational and transparent perspective, it is usually built for academic exploration, not a clinical use. And coming to the aggregated insights, it is mostly focused on population trends, not individual prediction. And this is the most important factor where the prediction will be the most which will be playing the most vital role. And coming to the conclusion and future directions, I successfully built classifiers, random forest outperformed logistic regression, identified key predictors, impulsiveness, concertiousness, and age. So coming to the future perspective, so we have to implement this on the multi-drug classification, deep learning for the better accuracy, cross-validation for stronger generalization. And I would like to acknowledge to UCI drug consumption dataset and research on model explainability like SHARP by Rebero et al. This research is strictly for educational and analytical use only. Thank you for your time and attention. I'm happy to answer any of the questions or discuss potential future improvements. You can reach me out uh, by using my email ID and in using machine learning responsibly for the public health challenges. So the successful classification usually obtained by class balancing where random forest and logic regression models usually work well. So I thank everyone for giving me this opportunity and I thank Willard professor and the TA teaching assistant who has continuously supporting us and guiding us in making us learn a lot through this course by implementing all the practical activities day to day whenever the coursework happened. So thank you so much for giving me this opportunity. And with this, I conclude. Thank you so much.